Very good morning, everyone. This is new territory for me because normally I look after sessions involving hardcore research. But when I was asked to do this, I looked at the names of the people who will be on the panel, and I was absolutely astounded by how come with their backgrounds they're stealing our territory, you see. And until I started reading about them, I discovered they're real adventurers, they're real pioneers, these people who are joining us now. So without any further delay, because there were some questions which were raised in the previous session, and I would like to be able to answer some of these questions. So I'd like to welcome my three panelists to join me here on the stage. Pierre Faucoup is here. Please, can you join me, please, Pierre? Pierre is from the Exploration Company. Welcome, Pierre. Thank you. Yeah, anywhere you want. Good morning, anywhere you want. Finally, we meet. And also we have, we've heard him ask some questions earlier. Daynan Crull from Karman Plus. Daynan, please join me on the stage. Good morning. Anywhere you feel comfortable. And finally, you've already heard him speak earlier. Gary, you around? Sorry, I can't see you because the light is in my face. Good morning, Gary. So I'll try and answer some of the questions that were addressed earlier. But as I said, this is really new territory for me because, seriously, these guys are pioneers. And they have, looking at their background, speaking to them yesterday, they have taken a giant leap. For me, it looks like into the dark, but clearly they have seen light of different wavelengths, but they have seen it, which I cannot see. And I'd like to address some of these issues that were raised earlier. Can I start with you first, Gary? One of the things that surprises me is that it looks like you're a one-product company. Helium-3. Isn't that dangerous in terms of your future and your funding and what you're planning to do?
Yeah, so we believe helium-3 is the right go-to-market strategy for the reasons that I said before. It is a high-priced product. It is rare on Earth. It is relatively abundant on the moon. That doesn't mean that we would stop there. It is the hardest problem, we think, in terms of what you need, the infrastructure and the technology and the conditions you need in order to harvest it. Once we have that operation, it would be relatively, not easy, but in comparison, less challenging to take another part of that very large regolith stream and perform a ISRU on it. Also, the technologies we're developing, I believe Daynan asked a question about this. They have applicability on Earth too. Some of the basic technologies that we're developing could be used to refine helium-3 on Earth, but it could also be used in other cryogenic applications, other mining applications. So we view ourselves, yes, we're selling helium-3 as a product, but we are a technology company at heart.
I'm going to push you a bit further also about these contracts which you have signed already. I was sitting there listening to you, and you told me about that yesterday, and it looks to me like if I go to Morocco and say, I want to buy your sardine production in 2030, all of it, and I give them money for that price, you see, and you don't know what the conditions are going to be. It's like buying future coffee in the year 2060, So how did they trust you so much to part away with their money? Is it a small amount or is it a big amount? Are there penalty clauses if you don't deliver or what?
Yeah, so what we're doing is not, in terms of contract structure, it's not at all without precedent. Number one, all these companies that are customers desperately need the resource. They see that it is impacting their growth, and in the case of the Department of Energy, impacting national security without it, and there is no substitute. But if you look at, for example, the structure of how oil and gas exploration is done, it is also, although that is a much larger case of commodity, in order to do new oil extraction and new exploration and extraction, it is a years-long investment project to do an exploration drill, to put an offshore platform, and it is price sensitive. So that's more of the model that we're looking at.
Okay, thank you. Daynan, can I jump over to you? Because on your website you also mentioned helium, and it's one of the things that is mentioned, but you also emphasize that you want to move polluting industries away from Earth into the atmosphere, into outer space. Can you elaborate a bit on that, what your vision is, how you hope to accomplish any of this?
Yeah, absolutely. So when you look at some of the prevailing theories for how a lot of the material arrived in the Earth's crust that we're excavating, the early bombardment period of asteroids is often named as one of those sources. And so it's long been suspected that the asteroids would contain a lot of the resources that we would need eventually, certainly at larger scales. The question has always been how to access, of course. That's a fairly big question. So when we think about the fact that the space industry itself has gone through transformational changes in the last couple decades, and I don't want to overstate that, but it really is clear, even as I look at the audience, the amount of companies and energy and power that's going into looking into the space industry is growing rapidly, making that accessibility question change fundamentally. So we're now looking at the ability to access asteroids and get to the resources that we know we're excavating here on Earth, and even the things that we're excavating that are abundant cause environmental and geopolitical externalities. So we can see that. And so the idea that we could actually be accessing these resources, processing them to produce what we need here on Earth as well as space, for us is sort of the flagpole on the horizon. We see that the sort of paradigm shift of that transformational infrastructure in space really can only be possible when the mass required for that structure, as well as the resources we're finding, are found in space. And that would actually be the ability to pull, mining itself off of Earth, but also other heavy industry that might be well suited for that sort of environment. And of course, everything needs resources, including water. So that's sort of that's the long-term vision, and happy to talk more about the roadmap to that. But that's the driving force behind that.
And you also talk about mining asteroids.
Absolutely.
And you talk about going there and doing things, and whether you bring them back or establish. I mean, we've had this morning a few interesting presentations, particularly, I found the first one was really extremely good, because she laid the foundation of parts of this discussion, in terms of, and I'll come back to Pierre with that. Yeah. So how, have you got any launches planned? Are you share launching with anyone, the payload or whatever it is? What's your mission?
Yeah, so we do have, we've purchased a launch on a Transporter 19, which is a SpaceX rideshare to LEO in February of 2027. It's a sun-synchronous orbit, so we'll be going under our own power from that to a heliocentric orbit. So it'll be a complex maneuver, but this allows us to keep the total cost down. We bought that launch for $4.5 million. And so as we build the spacecraft that will take us to that asteroid, we believe we can keep the total mission cost quite low. We're looking to prove out the ability as a company to develop a spacecraft capable of deep space missions and going to the surface of an asteroid and extracting material. That's our goal for this mission. We hope to accomplish that by mid-2028. Obviously, the follow-on missions will require extracting and processing material we find, including water. That's the focus for us. And as a note on that, and I'll just say for us, the driver for this is, water is a resource. If you think about the economics of resources, you want to know, the volume of the resources you're after, the level of effort required to get them, and the demand. These are sort of pieces of the puzzle that come together. And so I certainly, and I don't say this to diminish the work with the lunar activity, but I say let's use this to leverage more interest in asteroids, in that I'm challenged with the question of effort for water on the moon, because we still have a lot of questions we need to answer there. Whereas we have had 2 sample return missions to asteroids that both have indicated the presence of water. I've yet to see the data on Bennu, but the Ryugu data suggests 4 to 7% water by mass. So that is identified hydrated minerals that we found. So we know the water's in these objects. The issue of access is a challenging one too. If you think perceptively that these are asteroids out there, they're small, we don't know much about them. But if you look at things like the delta V required to get them, they're much closer than people realize. The asteroids we're targeting will take a cruise time of a few months at most. And so if you think about a scaled operation that is going to asteroids where we know the water's there, we understand to the degree the accessibility required to get there. There's some question about how to extract the water, which we're working on, but I think that would apply to a lot of the lunar activity as well. So for us, this seems to be a clearer path to more scalable resources. And so that's how we're angling a lot of our initial missions.
Have you signed any big contracts?
No, and I certainly applaud Interlune. I think that's a great model for a number of reasons.
Yeah.
I think the purchase order model not only sets a sort of precedent for how you want to do the business. There's a great discussion yesterday in terms of policy, and I think that's another advantage is being clear. We'd love to be transparent about what we're doing, what we're getting, and who we're selling it to. So we don't have any purchase orders to announce, but that is certainly something that I think is a great model to follow.
Well, keep your fingers crossed for that.
Yeah.
I mean, you talked about paradigm shift, and actually what you're doing, what you 3 are doing is really a paradigm shift in terms of our ambitions, how to get there, what to do. So can I jump to you, Pierre, because you have tier 1 funding for your company. It's really very well funded, and you're talking about reusable ships, etc. But you also talk about the resources themselves. You talk about helium, you talk about methane, you talk about other things. Can you elaborate a bit more about? You've been very quiet, you see, so far in this meeting.
Don't worry. Thank you. So first, the mission of the exploration company is to provide logistics services and to develop vehicles able to provide these logistics services. So first, as explained yesterday, first for the LEO destination and later for the moon destination. So we'll provide solutions to go from Earth to moon and from moon to moon with Hopper. So we were already developing and thinking about these solutions. And for sure, we are designing these solutions to be able to use the resources which will be available on the moon. For example, we have the engine we'll use for our lunar vehicle will be a LOX methane engine. That means that we won't exploit the resources directly on the moon, but we will be a user of these resources with a product which will be produced in situ by the others. And we'll offer them solutions to go from one exploitation site to another exploitation site, or to offer solutions to go from moon back to Earth.
And what do you, in terms of the team that you have at the moment, because you're looking at your website, again, you have a huge team, but in terms of the engineering and the team that will deliver these things, how big is that team? It's not mentioned in there. How do you aim to achieve all of this?
First, we are growing fast because, as I explained, we have been created 4 years ago. We are now roughly more than 270 people. We expect to be more than 300 before the end of the year. So we are mixing senior people with very well experience, with previous experiences in well-known space companies, and of course young talented people with a lot of energy and a lot of perspective to offer. So, and we are concentrating our competencies on each site in accordance with all the economical situation of the site. For example, in Bordeaux, when we are based in France, we are developing our engine competencies because it's a site where you can find easily other people who has this kind of competencies. The same in Germany, we have all of our onboard computing, things like that, which are developed there, because it's related to already existing competencies in this region.
That's interesting, because most of the people, if you look at the posters outside, you know, the people are disseminating the research. It's made available to the public. But you must have hit some stumbling blocks where people keep the information to themselves and do not want to disseminate that information. Daynan, you actually do mention this specifically, in that you spoke to people in government, companies, university labs, and you found that this secrecy is a stumbling block, a major issue. It stops the learning process and the feedbacks. Can you elaborate a bit more on this?
Yeah, and I think part of it is my ability to say I'm coming from outside the aerospace industry. And so I can ask dumb questions. And what I found that was surprising is I started asking questions to our vendors, to people in the industry, and the answer was just, well, that's just not data we reveal. Or I got frustrated with the lack of transparency, and it seemed that people were just it was normalized. And I'm not even talking about classified information here. I'm talking about vendors that provide data sheets on certain products and then are unable to produce other results in terms of additional testing. We found that that's actually one of the biggest direct issues that we faced, is the lack of information on product development. And it's one of the reasons we took a number of things in-house, is not initially that we wanted to, but we just found that the data that we were getting from the vendors did not match whatsoever the product that they were actually delivering to us, or were planning to. And there's sort of an opacity to the industry in that sense, including the pricing on some of these things, ranging from gimbals to thrusters and cameras. And so part of what our drive has been is to say, look, we're trying to understand what it takes to develop a product like this, to space qualify it, to do the environmental and the radiation testing necessary for that, and then try to be transparent to that in a way that we feel comfortable selling to a vendor or a customer if we were to produce this. And not to be too cynical, but I think a lot of the purchases of these components were made by people that had a budget already set and were not wanting to take a risk on something, and as long as the product met their specs, again, according to the data sheet, they didn't ask questions about where the cost came from. Everything is non-recurring engineering, every single thing. So everything that's made has something that doesn't recur, apparently. So we got frustrated with that, and part of our drive is to try to be a little bit more transparent about that. Now that's getting into the weeds on sort of like how you build a spacecraft, but I think in the bigger picture too, we've been frustrated with other companies, including new startups, who have been just very secret about what their plans are, or where they're going or what they're doing. And we've offered at a number of conferences the asteroids that we're interested in, and have appealed to the research community to say, hey, we think we're going to go here, we're not sure, but if you're interested in doing research, let us know, we'll work with you, let's publish some papers on it, because we're going to make our money selling regolith, not hoarding data. So I don't know, I think, and that comes from my business partner and I just have had a background in trying to be transparent in the work we're doing, and I think I can see more of that happening in the space industry, but it does seem to be a bit slow to turn around.
You mentioned the figure 5 million earlier. I'll have to admit, this is the smallest amount I've heard being mentioned throughout this meeting, It's billions and billions and billions, So this is quite...
Well, let's talk transparency. I think that's the era we're in. So you can go to launch.spacex.com, and there's a button, book a launch, and you can go and you can enter data related to your spacecraft, including obviously the mass, and you can get an estimate for what the cost is, which is what we did. And then I purchased a launch in December. And the launch I purchased was, just under about $4.5 to $5 million for the size of spacecraft we're launching. Now, we'll have to do a great deal of integration, assembly, all the stuff that needs to happen, and there's costs associated with it all over the place. But for me, this is an example of where the industry can go. There's a product that's offered, and it's clear what it is. Now, again, we're going to low Earth orbit. We're not getting a higher energy orbit, which would be another $15 to $20 million on top of that if we were to try to do that. We looked into it. But yeah, that's...
Thank you for that. Going from the 5 million, the estimated market of helium-3 on Earth in 2030 is like 800 million or something of that figure. And Gary, you clearly have cracked a nut in here, because you must have developed some technology which is proprietary to you. So have you actually filed any patents to protect that technology? And if so, if you filed it, can you tell us about it?
We're always very careful to talk about patents. It is the one area that until you get to a certain stage, you do want to be a bit secretive about. But yes, we have IP protection, multiple sources around some of the basic techniques we're developing. But patents aren't the only way to protect IP. Trade secrets are another way. The patent requires disclosure of the invention, and it's sometimes difficult to defend. Whereas a trade secret, if you have a technique that is very difficult to replicate, you might just want to keep it secret without disclosing it. But IP protection is, like for any startup, high-tech startup, is a very core part of our business. And that maybe goes a little bit against, at least in terms of the secret sauce around being open.
I just want to address a question which was raised earlier in terms of the feasibility of all of this, because the concentration of helium-3 on Earth is something like 0.0001% of the helium concentration, not on the planet, but of the helium concentration. Now, a question was raised earlier about what the concentration on the moon is, and you must have based your predictions on some model which will tell you that, okay, there's a scatter graph in here which shows me it's there, but there must be something beyond that. You must be confident about this. Can you talk about that a bit more?
Absolutely, I'd love to. So primarily starting with the sample analysis from the Apollo missions, the helium-3 was measured directly by heating the sample and using a mass spectrometer. And the researchers, and one of those is Harrison Schmitt, who is one of our founders, Apollo 17 astronaut, found there was a very strong linear correlation between helium-3 concentration and ilmenite concentration, as well as optical maturity. And you can almost draw a line through that. And when you look, you can detect ilmenite concentration primarily through titanium, and as well as optical maturity from orbit. So when you plot maps of ilmenite and optical maturity, you find that the Apollo missions didn't happen to land on the very highest predicted helium-3 areas. There are areas that are much, much higher, and they were in that map that I showed. So we are confident that there is a relationship. We want to use Prospect Moon to land at the very highest site on the moon and prove that concentration, that prediction, which is much higher than what was measured in Apollo on any mission, that holds at those very high levels. So our predictions, if you look at literature about like concentrations of helium-3 that are on the moon, that's just where they happen to land and happen to sample. That would be like going to a random place on Earth and seeing how much gold was there. Wouldn't tell you that you had found an ore concentration.
Okay, well, thank you for that. Pierre, if I may jump to you, because you described yourself as one of the fastest growing space company in the world.
In Europe, not in the world, but in Europe for sure.
And you talk about your models, which are Nix, Mistral, and Typhoon, and you talk about the market, which is going to grow from 5 to 50 billion a year for the transportation. And it's, as you say, it's at the moment is for the fortunate few. You want to be part of that. So your model is really interesting because you talk about launching, docking, re-entry and refurbish and sending back again. When do you think you'll be making money?
I think first we are defining specific business approach or specific business plan, which is mixing to consider that we will share the cost of our development between private fundings coming from our investors and from public institutions like agencies, and to have anchor customer to support us in the development of our product by offering our first demonstration mission. It's what we have done with ESA for our first Nix full-scale vehicle. We are sharing the price of the development between our investors and between ESA. And with this approach, we have, I could say, more freedom to define what will be a product we want to develop, answering to the needs of the market, so to fit much more to the market needs, and to go faster, because we are convinced that one key to be successful in this domain is to go faster and to have a very short loops with demonstrations, with tests, and what we have done until now. And with this approach to have first by using our money of our investors with their confidence, and we show that we are sticking to our schedule. We are demonstrating that we are in a business approach where you can go faster with a real knowledge on when we want to go, the point we want to go, and with the support of the agencies, which are pretty interesting to see this new way of making the programs. So with this approach, we are sure that we will make money, because for example, for the LEO destination, we have already signed contracts with CLDs. We have signed contracts for 5 missions. That means that there is an interest also of these CLDs that show that we are not out of the market, but really inside the market.
Excellent.
And with this recurring approach, we will be in position to make money.
Before I open this to questions, I just want to ask one final question to the three of you, which really bamboozled me. Daynan, you were a senior vice president at the Bank of America. So you're a data scientist.
There are a lot of senior vice presidents.
I know, but you were a data scientist, and you dabbled a bit in politics, and you worked here and there with New York City, and you must have been on a very comfortable life, very comfortable salary. Come to you as well, Gary. You were with Blue Origin. You were one of the first 20 to start that, and when you left it, there were 12,000 employees there. So 6 figures doesn't even begin to describe what your compensations were. Don't you have families? I mean, why would you give up such a big thing? Because you were self-funded to start with, Gary. And you were also self-funded to start with. So this is a really huge leap. So what made you do this? And you've taken risks. It must have affected you, must have affected everything around you as well. Very briefly, can you tell us in a few words before we open this to discussion?
Well, I'm cursed, I guess, with some restlessness. That may be one way. No, I've enjoyed an interesting career. There's a number of formative moments. In the year 2007, I was in finance, and a friend of mine decided to run for Congress in the United States, and he asked me to run his campaign. And I said, "You're crazy. I don't know anything about politics." But he stayed at it. I finally quit my job and went to go run his campaign. We lost. It was a hell of an effort, though. I felt like a failure. I felt like I lost people's money. It was, for me, sort of a low point. But it also taught me something. It was just, there is no other way, if you're going to even think about doing something that has potential impact, other than to just go step out and do it. And the other thing I learned is I survived, and I was fine. Financially, I bounced a check at a sandwich shop. That was not a fun time. But what I found is that what I needed the most was an understanding of my own abilities and the ability to find opportunities. If I had confidence in that, then I could handle what the storms brought to me. And so that carried forward through my career, even
Okay, I don't want your life story.
Fair enough. Well, what it brought me to the idea that there's something really, I think, important about understanding resources. This is a challenge that not many people would be willing to look at, I think, this early stage. Maybe I'm one of them, and the people that I work with are.
And Gary?
Yeah, so sort of like that. I only like to work on things that most people think are crazy, but if they're wrong, it will change the world. And I started my career in the late 90s working on reusable launch vehicles when most of the industry was very skeptical. And at Blue Origin, I led the technical team of the New Shepard program, when most people thought space tourism was crazy, and then flew on it myself as well. And now Interlune. So when I get comfortable in the circumstance, I start to look around.
Thank you so much for that. Lisa, do I have any time for questions, or shall I wind it up? 2 minutes. Does anybody have any urgent questions, burning questions, something that can't wait? Otherwise, you can talk to them afterwards. Anything? Sorry, I can't see from here. Yeah. It has to be a quick question with a quick answer. Yes or no?
I'll do my best. So, Michel Cardin, Imperial College London. It's a Space Resource Week, but I wonder, is there, what do you guys think? Is there a market for future data systems and intelligence?
I think, Daynan, that's, yes.
Yes.
Thank you so much. And I think this is the first time I've actually managed to stick to time ever. Because normally I get told off, but this time I've managed it. It's been really a great honor to sit down with you three and to talk to you today and have a chat with you yesterday. And I'm sure you'll all join me in thanking them in the normal way. Thank you so much indeed.
Thank you, Maher. Thank you again to all of the panel. And I'm not going to keep you either. It's coffee break now. Back in the room here, we're going to talk about policy planning and economics, making ISRU ISRU work. And then in the delegates room, we have two sessions in parallel. One is Lab to Market, and the other one is Commercial Initiatives Workshops on the economics of it as well. So enjoy your coffee break, and we'll start at 11 in both rooms. Thank you.